All right, today we're going to dig into something really interesting. It's this super subtle but incredibly powerful vulnerability that's hiding inside a very common Solana function. And it's just a perfect example of how a tool that's supposed to make your life easier can sometimes hide a really nasty surprise. So let me ask you this. What if a simple shortcut, one that's designed to save you time and effort, could actually be turned against you? What if an attacker could use it to just permanently break a piece of your app? That's exactly the kind of hidden trap we're talking about today. Okay, so first things first, let's get to know the main character in our story. We're talking about creating accounts on Solana, and specifically this one tool that looks like the perfect, convenient, all-in-one solution. And that tool is the Create Account instruction. Honestly, you can think of it like an all-in-one installer for a new account on Solana, right? Instead of having to run 3 different commands, you just use this one. It's supposed to do everything for you, allocate the space, fund the account so it can pay its rent, and assign an owner. It's all wrapped up in a nice, tidy package. And this is what that convenience looks like under the hood. The Create Account function is basically bundling these 3 essential steps. First, it allocates the space on the blockchain. Then it transfers the money, the Lamports, to cover the account's rent. And finally, it assigns ownership to the right program. Looks super simple, right? Well, maybe a little too simple. Yeah, not so fast. Because that convenience, that neat little package, that's exactly where the problem is hiding. So let's get into the hidden denial of service vulnerability and see how an attacker can actually lay the trap. So the attack we're talking about is a persistent denial of service, or DoS. But I want to be super clear here. We're not talking about your app being slow for a few minutes. We're talking about an attacker being able to permanently block a feature of your application from ever working again. It's like someone putting a permanent lock on a door you need to open. So how do they actually pull this off? You'd think it would be some complex hack, but it's shockingly simple. It's just a 3-step plan. First, the attacker predicts the address that your app is about to create. With program-derived addresses, this is often really easy to do. Second, they front-run you. They send a tiny, tiny amount of crypto to that address before you can. And that's it. That's the trap. That little bit of pre-funding causes your app's Create Account call to fail. Not just once, but forever. And get this is what's really wild. How much does it cost an attacker to spring this permanent trap? Just one single Lamport. That's the smallest unit of currency on Solana. For practically nothing, they can lock up a part of your program for good. Okay, so the big question is, why? Why does one tiny Lamport break everything? To understand that, we need to pop the hood and look at the code itself. So let's figure out why Create Account actually fails. And you're not going to believe this, but this entire powerful, persistent vulnerability, it all comes down to a single line of code. Just one simple check that's based on a really flawed assumption. And here it is. This is the smoking gun. This little snippet of code is the root of the whole problem. All it does is ask a very simple question. Hey, does this account we're about to create already have a balance greater than 0? And if the answer is yes, bam, it just stops everything and throws an error saying the account is already in use. And that's the key right there. The whole problem is in how the function defines account already in use. To this function, any account with any balance at all, even just one Lamport, is considered in use. It doesn't matter that the account is totally empty, has no data, and doesn't even have the right owner. That super simplistic check is the entire vulnerability. Okay, so we've seen the trap. We know why it works. Now, how do we get out of it? How do we disarm it? Well, that brings us to the safer manual fix. The solution, when you think about it, is actually pretty straightforward. You just have to ditch that convenient all-in-one Create Account function. Instead of letting it do everything for you, you take back control and perform its 3 steps manually. And this comparison really lays it all out. On the left, you've got the vulnerable path, using that all-in-one function, which just fails if there's even one Lamport there. But on the right, you have the safe path. You break the process down into its 3 pieces: transfer, allocate, and assign. And that works perfectly, even if an attacker has already pre-funded the account. So let's walk through that safe flow, step by step. First, you transfer whatever Lamports are needed to make the account rent exempt. This step doesn't care if there's already a small balance, it just tops it up. Then second, you allocate the space you need for your data. And finally, third, you assign the account to the correct owner program. By doing it this way, you completely sidestep that broken is the balance greater than zero check. Now, you might be thinking, okay, that's great, but doing that manually every single time sounds like a pain. And you're right. Luckily, we've got modern tools that can help. This is where Anchor comes in. Think of it as your automated guardian. So, Anchor is a super popular development framework for Solana, and it has this awesome built-in feature called AccountInit. It basically automates this whole protection for you. When you use it, Anchor is smart enough to generate the safer code behind the scenes, so you don't even have to think about this kind of hidden trap. And this table shows you exactly how smart Anchor's logic is. It's actually pretty simple. Before it does anything, it just checks the account balance. If the balance is 0, great. It uses the fast, efficient create account function. But if it sees that the balance is greater than 0, it automatically switches gears and uses the safer, manual 3-step method. It's got the fallback plan built right in, protecting you by default. All right, let's wrap this up with the key takeaways. First, that create account function, it's a handy shortcut, but it has a hidden flaw. Second, an attacker can use that flaw to pre-fund an address and cause a permanent DoS. Third, the whole thing fails because of one simple check for a non-zero balance. Fourth, the fix is to do it manually, transfer, allocate, and then assign. And finally, the good news is that modern frameworks like Anchor are smart enough to do this for you automatically. So when you boil it all down, this whole vulnerability wasn't some crazy complex hack. It was just a simple, flawed assumption hiding inside a tool that was built for convenience. And that really makes you think, right? Makes you wonder, what other hidden assumptions are lurking in the tools you use every single day?